I want to start up in the upper left-hand corner here with this Simpson 260. And if you're looking for a how to use multimeters or which multimeter to buy video, this isn't it. There are lots of those on YouTube. I've even made a few myself. But today I'm just going to be giving you an overview of multimeters and their evolution, if you will. Back in the days of vintage radio, in other words, pre-war, there were meters like this Simpson. They were called volt-ohm milliamp meters, and so they tended to be called VOMs. This is a very nice VOM. It has a very high input impedance for this kind of meter. We'll talk about that a little bit later. Down here you see a couple of smaller meters which actually were more typical of the 20s and 30s. Many of the early meters were only 1,000 ohms per volt. That's what this one is. By the way, if you see all these have these no bat signs on them, that's because I remove the batteries from these when I store them, and so I've taken this a lot of these out of storage, but I did not put the batteries back in. Now, that points out an interesting thing about VOMs. They don't need power except for the resistance ranges. In other words, you can read voltage and current with these meters without any battery at all. So this one is 1,000 ohms per volt. This one is 2,000 ohms per volt. This one to the right is 20,000 ohms per volt. What does all that mean? Well, without getting into any technical details, it just means higher input impedance loads the circuit less. So you get a more accurate reading because the meter doesn't pull down the voltage in the circuit. Now, it was because of the fact that even a 20,000 ohm per volt, and there are even some that are 100,000 ohms per volt, but you reached a limit because of the meter movements that are being used of how little loading you could put on a circuit. And by the way, this is a modern 20,000 ohms per volt meter. I say modern, I probably bought it 20 years ago, but they still make these. But what that led to was the development of what are called vacuum tube voltmeters. And that's this one. Let me turn that around and show you what's inside first. Okay, now I've turned the meter around, and let me zoom in on it a little bit so you can see better what I'm talking about. In order to get higher input impedance, the designers began to use vacuum tubes like this one and this one. This vacuum tube is a dual triode that's used in a little bridge circuit. And this is a 6AL5 rectifier tube that's used to convert AC signals to DC so it can be read on a DC meter. By the way, all of these meters basically read DC, and for AC they contain some kind of rectifier. So what designers did, and this began even in the 1930s and by the 40s was fairly common, was they built a meter with a vacuum tube in it. That allowed them to use much higher input impedance, or at least the meter had higher input impedance. But one drawback is what you see here. You had to plug them in. So these were vacuum tube voltmeters were used especially in higher impedance circuits. So in other words, the idea is this meter produces a more accurate reading just because it doesn't load the circuit very much. Most of these meters back in the day had an input impedance of 11 megohm. The basic meter had a 10 meg input impedance, and then there was usually a 1 meg resistor in the probe. Okay, let's move on down and look at some of the rest of these meters. Of course, one of the drawbacks of the vacuum tube voltmeter was it tended to have to be plugged in because batteries didn't last very long with vacuum tubes. So as semiconductors, transistors, and so on began to be available, the whole multimeter industry, if you will, split into two parts. One was trying to build a meter like this one. This is a very early electronic voltmeter. In other words, this uses a battery, so it doesn't consume as much power as a VTVM, but it basically is, the internals are like a VTVM, but it displays as a digital readout. So this is one of the early digital meters. But there also was a movement to produce analog meters that were like VTVMs but used field effect transistors. This is one that was produced by NTE. This one down here is by Tenma, and basically they have high input impedance like this meter and like the old VTVMs. In other words, 11 meg input impedance, but they run on batteries and they display on an analog meter, which can be very convenient, particularly if you are varying something. The human mind, at least most of the people I know, including me, find it more intuitive to watch a meter moving up and down than to read a digital readout and figure out. Now, a digital readout's fine if the voltage is steady. But if you've ever tried to figure out when this thing is flashing around and changing and so on, whether the voltage is going up or down, you'll see why that an analog meter like this can sometimes be much more convenient. Now, by and large, these have disappeared. And if you watched my sort of mini review of that Amazon multimeter a few weeks ago, you'll know that some manufacturers have started putting an analog-like display into the digital readout. It's not quite as good as these meters are, but it's an attempt to fill the gap. And then on the far right are meters that were designed to be clamped around. Now, they can also be connected. Notice this one has test probes, and so does this one. They come out the bottom here. But the main claim to fame of these meters is they have a clamp which senses current. Now, the clamp can be either an inductor, in which case it will only really work with AC current, or it can be a Hall effect device, in which case it'll work with both AC and DC. So, this is an example of the evolution of multimeters over the years. Now, there's a lot more that we could say about this, but the main thing I want to emphasize, and I'll try to do this in all of my videos having to do with the electronic workbench, it's hard to damage any of these meters on the voltage scale. If you accidentally leave a meter in the resistance scale and hook it to a circuit, you can damage the meters that way. So, just be sure if you're using the meter that you always return it to a high voltage scale, and then you're unlikely to damage the meter by touching it to the wrong point in the circuit. Also, if you use a meter to measure current, be sure you know what you're doing, because you can not only damage the meter, but you can actually cause a fire if you, particularly in older meters that don't have all the Category 3 and Category 4 protections of modern meters. If you hook up a multimeter to measure current and you don't know what you're doing, you not only can blow up the meter, but you can cause a fire and perhaps, depending on whether you're holding the meter or not, even damage yourself. So, in order of safety, generally, if you have the meter set to a high voltage scale, like 1,000 volts, and I recommend you start there, and you measure a circuit point, it may not deflect very much, or it may show a very low voltage value. But then you can lower the range until you get to a reasonable reading. that is almost guaranteed to protect the meter, and as long as you're careful with how you use the probes, protect you as well. If you're going to use a meter like this for resistance reading, or one like this, or a modern one like the Amazon meter that I referred to earlier, which is this one. If you're using these on a resistance scale and you apply it to a circuit that is still powered or that has big capacitors that are still charged, you can damage the meter. You can also cause sparks and even possibly a fire. But the place where you need to pay the most attention is when you're trying to measure current. And that's the reason why it's always safer to use, and why I included these. You probably should get, if you're going to be measuring current, like the pull of a car battery, or the amount of current that an air conditioner is drawing, or whatever, then use a clamp meter. Don't try to use meters like this to measure current. If you want to, you can buy some fairly expensive fluke meters, and they work quite well and will measure quite low current values. So if I were going to use a meter out of my current collection, which one or ones would I use? I'd use this meter for digital. This is the ACEG MET, and I've found it to be a very reliable, very good meter. I reviewed it in a mini review a few videos ago, but this would be my first. Now, if I couldn't find that one, I would be using this one. This is the BT meter, the BT, what is that, 39C, that I reviewed and chose in the Frugal Repairman series. My second meter, and by the way, not my second choice, this would be my second choice, but my second meter would be this Radio Shack 20,000 ohms per volt ohm milliamp meter. However, I doubt you're going to find this one. So if you can't find one like this, what would my second choice analog meter be? It would be this, a meter that I haven't reviewed, but that is available for about $22 on Amazon, called the GMT319. It has the same basic features as that Radio Shack. It's a little bit physically larger, and I like small meters, but it does have a nice, fairly large analog meter reading, and it also has a battery test scale, although frankly you can test a battery fine with almost any meter if you just know what voltage it's supposed to read. So those are what I would get. Now, let me say, some people have questioned why I don't tout fluke, and the reason is that, frankly, I don't market anyone's products. I have no connection with any company of any kind whatsoever. I'm completely retired. Everything I look at, I buy with my own money. I don't even review stuff that is sent to me. In fact, if something is sent to me, I try it, and then I set it aside. I'd never put it in a video because I do not want to encourage people to send me things. However, would I buy a fluke? And the answer is yes. If I were a professional electrician, especially working in the field, I would buy probably a fluke. Now, I wouldn't buy the latest because I think they're a little bit overpriced, but I might, for example, buy a Fluke 87 or a 189 or something in that group. But to my mind, this meter, the ACE-GMET, is every bit as good as a Fluke, but Fluke stands behind their products, and that would be important. If you dropped it and whatever, you can get parts or get a repair for it. There was a time a few years ago, and you may have heard, when they weren't really very responsive, but I think they fixed that. So I would buy a Fluke today, but only if I were a professional electrician where I could only carry one meter and it kind of had to do everything. Now, if I were buying a meter for accuracy on the bench, what would I buy? Well, let me show you that. For accuracy and features and value, I would buy something like this Keithley 2015 THD. Now, it has some features that very few multimeters have, including the ability to measure total harmonic distortion. Now, these are no longer made, but there are a zillion of them out there on eBay. I think I paid around $200 for this one. They may be a little more than that now, but if you buy from a reputable dealer, there's a huge number of these meters on the market because they have come out of service. And why would I pick this? It's very accurate, recently calibrated. In fact, I bought it from a calibration center. It has a lot of good features, and frankly, it's very reliable. That's why there's so many used ones out there. So if I were doing just a meter for just 1 meter, but I needed high precision, I would get the Keithley. Okay, well, I hope that gives you an idea of multimeters. And once again, hope you enjoyed the video, and look forward to some more in the Workbench Electronics Workbench series. But for now, stay safe and have a nice day.